So I want to go ahead and take a moment to go back to our scene properties here. We didn't talk about these much, and I want to go ahead and talk about them right now. Before we do, though, I'm going to go ahead and take our bottom platform, give it some rotation, scale it up a little bit. That way we can really see what's going on here. Yep, I'm just scaling it just to get a slightly different effect so we can notice how gravity and speed of our simulation world affect the actual physics simulation. Now, if we go back to frame 1 and we play this back, you'll see that everything rolls down just like normal. However, remember, we have gravity. Now, what's really cool about the gravity settings in Blender is that we can, of course, change the z direction of gravity, which is the down force of gravity. This is set to the actual gravity in the real world, negative 9.8 meters a second squared. However, we can set this to negative 100, which is not very realistic for Earth, but let's go ahead and play this back. Notice how much faster everything falls and accelerates towards the bottom of the scene. Very cool, right? However, don't forget, that is just the z downforce. If we wanted to, we could send it in the x direction. So if I set our z to 0 and our x to 100, and we press play, let's see what happens. Everything goes flying out of the scene. Now let's try to give it a slight downforce of negative 50. You see that? Look at that. That is really cool. Now, as you can see, everything will fly off the scene to the right because our x value is at 100 and our z value is negative 50. Now I'm going to go ahead and set this back to negative 9.8 because that's what it is naturally. And now if we go back and we play this back again, you'll see that everything falls normally. Now, this is just the gravity. There's other settings we can change in our rigid body world down here. You'll see we have a speed value. This is the speed of the simulation. So right now it's set to 1, so it should look pretty natural. We could set it to 4, and let's go ahead and see what result we get. Again, it's almost as if we turned up the gravity, but that's not really what we're doing here. We're actually just speeding up the process of the simulation, almost like fast forwarding it in a way. Let's set it to 10. And this should roll off the platform pretty quickly here. Now, the reason this is useful, believe it or not, is actually to create more realistic animations and physics simulations. Sometimes, depending on the size, the scale, the weight of your objects, when we play this back, it may not necessarily look very realistic. But if we fine-tune this speed to something like maybe 2.5, we may get something that looks a little bit more realistic. In my opinion, this looks more realistic. When we fine-tune this number, we can find a value that works best for our scene. And if we refer back to real footage and we look at these visual examples of real things rolling off of surfaces, we can actually get very, very close to the exact timing if you were to have this simulated in real life. I'll briefly go over substeps just to give you guys an idea of what substeps do. Basically, what substeps per frame mean is how often Blender is calculating those physics. The higher that this number is, the more accurate the simulation is, but the slower that it will take to calculate. The longer it'll take to calculate these actual physics simulations. And what's really great about Blender is if you hover over something, it'll tell you exactly what it is, right? It'll tell you the exact description of that value that you're going to adjust. Now I'm going to go ahead and collapse the settings here because I wanted to brief over one more thing before we go into cache, which is field weights. Remember how earlier I talked about field weights and sort of what they are? Well, let's go ahead and mess with the gravity field weight. Right now, if we press play, we have gravity affecting everything normally. If I set this to 0.2, go ahead and play this back now, gravity does not affect our scene as much as it did before. This is really important because sometimes you're going to want to adjust the field weights of certain objects or particle systems, which we haven't learned about yet, and you want them only to be affected by certain gravitational forces or force fields. This is a really easy way to affect your overall scene. Remember, this is for your entire rigid body world, okay? Not for specific objects. We'll get into that later. So this is where baking comes into play and cache. So this is really important, and I'll show you that something you've probably already noticed. On our timeline right here, you see this little yellow kind of line. As we back it up, we press play, that yellow line will continue. What that yellow line represents is Blender actually calculating our physics. And if I play this all the way through, go back, if I play this all the way through, we should get that yellow line throughout. But if I go back to frame 1, right, and I take one of these spheres and duplicate it, notice how that line turns into sort of this caution line? That means that Blender said, oh, whoa, hold on a second, man. We got to recalculate that. You just added something new. Now, I have no idea what's going to happen. You need to give me a second to catch up. Here's where cache and baking come into play. Cache and baking are basically telling Blender, hey, please memorize this so every time I play it back, I get a smooth playback. Now, right now, if we play this, there's not many objects in the scene. Blender shouldn't have a hard time calculating that. But when you have a lot of objects in your scene, and I'm going to duplicate these like crazy to show you. I'm going to delete our camera and our light. I'm going to duplicate these a bunch, okay? Now, the reason I'm doing this, and I'm just using Shift-D to duplicate, is because when we play this back, you'll notice there's a FPS up here. Sometimes that'll go red, and that means that Blender's having a really hard time calculating everything. But we can make this a lot easier on Blender. How do we do that? By baking the simulation. You can see right now that if I adjust our end frame to 100, down here, our last frame of our simulation is 100. In our cache, we have the same options. We have a starting frame and an ending frame. I only want to bake out to frame 100, so I'm going to do frame 1 to 100. I'm going to click Bake. You'll see that Blender quickly bakes all of that, and now you'll see that there's the option to delete the bake. That means that I want Blender to clear the memory of everything it just learned about our physics simulation. But what's great is now I can easily scrub through our timeline, and I can know exactly what's happening at any single frame, and everything is pre-calculated for me. This is really useful when you have thousands of objects in your scene, which you eventually will throughout this course with particle simulations. That's where baking really comes in handy because you need to calculate so many different aspects of what's actually happening in your physics simulation, and Blender doesn't have time to keep recalculating, right? We're asking the computer to do a lot by constantly recalculating in real time, so when we bake, we ask Blender to memorize that. Remember, if I click delete bake right now, and I try to jump to a certain frame, if I add new objects, I shouldn't be able to do that because Blender hasn't memorized that yet. For example, if I go to frame 1, I duplicate these, okay? I just duplicated those. If I try to jump to frame 60, notice how they're not really doing anything? That's because Blender doesn't know how to calculate that yet. We always have to go back to frame 1 if we want to play this back.